Okay, hi everybody. Thanks for coming. So, it is said that every DDoS presentation starts with the first slide, what is DDoS? I'm trying to maybe make things a bit differently. When you speak with people outside of the security network industry, generally you get a few different opinions when you mention them DDoS attacks. One of them is DDoS attacks, they don't exist anymore, they're a thing of the past. You know, we patched everything up, right, 10 years ago. The truth is, no, we didn't. A second opinion you might encounter is that, come on, our ISP will help us. No, they won't, at least not the way you might think they will. And the third opinion is that when a DDoS is aimed at you, there's basically nothing you can do. Well, I'm here to show you that maybe that's not totally correct, as DDoS attacks are a fact of life on everyday internet, and working in a, let's say, security operations center at a DDoS mitigation provider, you can easily have anywhere between 5 to 15 DDoS attacks per day. So what are DDoS attacks? Well, they focus on service disruption, meaning that if you have a high profit e-commerce site running and somebody wants to see it down, they will use this exact method to accomplish that goal. But also sometimes DDoS attacks are just employed as a smokescreen, meaning to diverge your attention from, let's say, a breach, a data breach, or a defacement where not only your revenue but also your, let's say, customers' trust suffers. What this talk is and what it is not. So I'm trying to make this talk vendor independent, as you have like different providers out there, you have different appliances, all trying to solve the same problem. But generally they all utilize really similar practices and similar approaches to the same problem. So trends visualization and DDoS size and frequency as a function of time. So often you will see, well, sometimes you will see some visualization showing cyber attacks with like an Angry Birds fashion, jumping from one side planet of the other. Well, the truth is nobody has global visibility on DDoS attacks. Everybody has just their own representative viewpoint. Even the biggest enterprise-grade CDN providers don't see more than maybe 20–30% of all internet traffic. But still, even this allows us just to see how the trends in DDoS attacks are progressing. So here, well, first of all, it's a logarithmical scale. So the attacks at the top are by magnitudes larger than the attacks at the bottom, and where each dot represents a singular attack. As you can see, the attack size is not really growing, but the frequency is. Now, why is that? It's because things, let's say, ways people utilize DDoS attacks, they always exploit the same things, they always exploit the same protocols. They don't really change, or not such an abrupt pace, while the use of botnets and use of tools becomes more and more easier, let's say. Some history. So Synthwats, we had those things since the 90s, and we have them still today, obviously. But things like, I know, Smurf attacks, things like that are not so much common anymore. So a Smurf attack is when you spoof the victim source IP and you broadcast an ICMP echo request at the network's broadcast address. The ping of that is basically just an oversized ICMP packets, which will cause a buffer overflow, but it's still exploiting the bad implementation of the network stack. Since 2000, people were already using IRCs IRC to control botnets. From 2001, we already had the first DNS servers used as reflectors, and 15 years after, we still face the same problems. So just a year after the first big attack against the DNS root servers were initiated, as you know, the DNS root servers are the main servers that resolve the top level domains. So if you have a FQDN, so the dot, which is usually omitted, and DN stands for the root servers. Of course, we have more than 13 of them. We have, I think, like 500 something of them, which are mostly anycasted and pretty much redundant. Some of them are owned by universities, some by governments, some by armies. In 2003, the first DDoS mitigation services have arisen. So in 2003, this was the year where online casinos, gambling casinos, came to be. Now, at that time, this was like a gray area of the law because it wasn't really regulated, and they would make a lot of money in this business. So they got their first extortionist letters saying like, okay, we know you guys make $50,000 per month. We want a cut of that, or your site, your online casino, it goes down. So at that time, there was really no other option than to comply with it. But after some time, these online casinos, they got together, hired this guy named Barrett Leon to put the first DDoS mitigation service in place, which led to the imprisonment of the main organizers behind it. In 2012, Operation Abubble, it's not so really, let's say, significant in terms of technology, or it wasn't revolutionary, but I think it's important because it was a big operation, big DDoS attacks, a series of DDoS attacks aimed against big financial institutions in the United States. So that year gave the DDoS service mitigation industry a big boom. You can see here how the attack size is progressing. So in 2005, it was just 8 gigabits. 2014, 400 gigabits. 2015, the DD4BC and the Great Canyon of China. So I guess everybody knows about the Great Firewall of China. Well, the Great Canyon of China is a different mechanism with which they intercept traffic aimed at Baidu and insert it with a malicious JavaScript causing DDoS, specifically this time against GreatFire.org and GitHub, which were providing tools to circumvent the China's firewall. Yeah. Motivations. So we got a range of them. So revenge. So it happened one time, let's say there was this big company and this small company. And this small company, they stole the proprietary software of this big company. And they started making their own software. Now the big company, they couldn't really sue them because they were outside of their range of the law. So what did the big company do? They sponsored DDoS attacks lasting for, I think, a bit over a year, like continuous DDoS attacks against a small company. Blackmail, extortion, that's pretty, well known. Hacktivism also is the equivalent of, the technology equivalent of spraying graffiti on your government buildings, I guess. Business feud, I don't like your business, I want to see you down. It's not so uncommon, especially in specific industries where the competitors, they use these tactics. And also leveling up. Does anybody have an idea what that one means? Yeah. Also, Sony, it's a specific case, but I was aiming more for PvP. So like in online multiplayer games, you have like player versus player combat, where the guy who wins, he gets some XP, some items, and the guy who loses, yeah, he loses XP and blah, blah, blah. So what do? If they see that they're on the losing side, they just launch a DDoS attack against the server they both are connected to, which results in like dropping all the connected players, all the sessions, so they get to live to fight another day. Groups. Well, everybody knows this first one. Activism oriented, mostly. Lizard Squad, they were big like against DDoS attacks in the gaming industry. DD4BC, they're interesting because I like their name. It's pretty descriptive. It's basically DDoS for Bitcoin. You also have a copycat of DD4BC, Armada Collective, and so many groups, copycats, impersonators. This group operate sometimes in cells, so you cannot really know if certain texts are connected, although they claim to be, and so on. So this is a nice extortionist letter you might have gotten from the DD4BC if you're working in a big company, and it's very well put together. So first they introduce themselves, give some links on their previous activity, and then they demand the ransom, the extortion of 40 bitcoins, and they claim to have an UDP flood power of 400, 500 gigabits per second. And it's very well written, because even if you have never used Bitcoin in your life, just with this email, you would be able to make a payment. And they also leave a way to message them. And the interesting thing is, at the end, they say, we do bad things, but we keep our word. Extortionists, they don't keep their word. So if you're, I don't know, a big top management guy at a big company, you might you might have several different approaches to this. You might decide, okay, I'll just pay them off. This is like nothing for me. It's peanuts. Some of them pay them off, but still hire a DDoS mitigation service. So, yeah. Mechanisms. Why are DDoS attacks possible? Well, the truth is, for a variety of reasons, there isn't one correct answer to do it. But to try to put it into one sentence is just because of the way the internet was gradually built, because we rely on 80s technology, which were never meant to be deployed in such a way, use such a scale with several bad implementational ideas. So basically, if all the big heads got to do together, get to rewrite all of this during the night and reboot the internet, probably DDoS service providers would be out of their business, but no way that's going to happen. When it comes to DDoS attacks, we need to differentiate volumetric attacks versus resources starvation attacks, and infrastructure versus application attacks. So infrastructure attacks, they're like layer 3 and 4. Application attacks are obviously layer 7. Volumetric attack is attacks just aimed at using huge amount of bandwidth. So for instance, if you're, if you have your data center, it's multi-homed, you have your firewall, your IDS, your DDoS appliance, you think you're pretty much prepared for anything, but then suddenly a 200 gigabits per second DDoS attack comes your way, causes huge saturation. Your provider just null routes you because they don't want to route all this dirty traffic to you, and you're just there lying like a dead fish. Resources starvation attacks, they aim more at starving your infrastructure out of its resources. For instance, if you have, a load balancer capable of doing 10,000 concurrent connections, and a huge layer 7 flood comes and just takes all your resources. Legitimate users cannot connect. So it's basically a bit of a game who's got the bigger guns. It's very easy for an attacker to get more bandwidth than you have. Also, one important thing is bits per second versus packets per second. Usually when it comes to like, let's say, one of these mega attacks, which are classified as attacks of like 100 gigabits or more, everybody just mentions the gigabits, but packets per second are also an important metric here. Why? Because doing stateful analysis, doing packet switching, it takes a lot of resources. It takes a lot of CPU power. Now the network gear, the appliances you have, they all have a packet per second limit that they can inspect, that they can route and everything. I've seen appliances which had their CPU burn out when the PPS limit was hit. Stealth creeper attacks, so they can't be DDoS, but they do not have to be, and they are much harder to detect. These are things like slow loris or slow post attacks. Like slow loris is just when when the attacker sends a HTTP request, just one header at a time, and there is a delay of like 10, 20, 30 seconds between each header, keeping the connection open, utilizing your connection pool. That's it. Slow post works in a similar way, just utilizing the post method and with a pretty huge content length header. And then when it comes to sending the body, it just sends like 1 byte at a time. So getting the same effect. So how do these guys do this? Well, obviously they cannot like legally obtain such huge amount of bandwidth. They cannot go just to their ESP and asking, yeah, I need a higher, bigger uplink. Why? Because reasons. So they're utilizing botnets or DDoS for hire services, which are freely available. You can find a lot of them. Some of them have an hourly rate. Some of them have a rate per 15 minutes. Some of them have like fancy drop-down boxes where you can select your type of attack which you want to launch. One interesting thing about botnets is that in the last time, Linux botnets are becoming more and more widely seen. Why is that? Well, things like the XOR botnet, things like the I think it's called Bill Gates botnet. It's basically utilizing, they're just searching for Linux servers that have SSH open on the standard port without any access control, utilizing weak passwords with root login enabled. So just via brute force, they get access to it. They make curl pipe SH and they download an elf malware, and then they can do pretty much everything. Infrastructure DDoS. So the first 5, there are basically flags in the TCP header, which you can turn off and on, which are pretty normal in any TCP communication, but sometimes you just see them coming used in attacks, different combinations of it, and they're generally referred to as out-of-state floods. Why out-of-state floods? Because they're not part of any established TCP connection. So no TCP handshake has been made, so they just get dropped. There's also what is called the Xmas attack, like Christmas, because all of the flags in the TCP header are turned on, so it looks like a Christmas tree. And also TCP anomaly, which is basically a badly crafted TCP packet with, I don't know, they can have some TCP options in the payload because they're, badly crafted. SYN floods, they're like the most dangerous here, let's say, because they're hard to differentiate. Is it, are they spoofed? Are they valid clients? So yeah, they just leave a half open connection. And if you haven't tweaked your, TCP backlog, if you haven't decreased your TCP timeout to reasonable value, well, it's not going to turn out good to you. Jargon. Yeah, this is, I think, the most useless protocol I know. Maybe it was used to debugging purposes later. If somebody knows any valid use of jargon, please let me know. It runs on port 19, and when you connect to it, you just get a random stream of characters. DNS, we're going to talk about that later. ICMP is also there, although ICMP often it's not used as a direct attack vector. Sometimes you just see it as, back chatter, because if an UDP destination port is not available, you'll get back an ICMP message saying that. So in a reflection attack, yeah, you'll see it. RIP, specifically version RIP 1, because RIP 2 had authentication enabled. So for some reason, people are still using RIP routers on the internet with version 1. So you can use them also in a reflection attack to get their routes with a spoofed IP and aimed at your victim source address. SSDP, NTP, we're going to talk about them a bit later. So UDP-based amplification, why is it good for, and why, and what is it exactly? So often you'll hear the words amplification, no shots now. Usually you'll hear the word amplification and reflection used together. So how does it exactly work? Well, we have here our attacker with their command center, and he has a series of compromised machines. He has his own botnet, and then he finds some servers running some vulnerable services that he can exploit in some way. So this is where the amplification factor comes in, because with amplification you don't need so much resources on your side, because the request you're sending is much smaller than the response. So you'll get different amplification factors depending on which kind of protocol exploit, so to say, you use. Of course, you spoof the source IP because it's UDP, so there is no really state. It's just a fire and forget protocol, best effort delivery. That's all there is to. So yeah, we still have DNS reflection attacks, and we also have NTP amplification attacks. So as you know, NTP, network time protocol, how else would you synchronize your time? So NTP works like it's a hierarchical setup. So on the top you got an atomic clock, and then you got these different layers called stratuses. So stratus 1, they have an offset of just a few milliseconds. But it's not the problem NTP was built, but it's this specific command, get list, which you can use in NTP amplification attack. This command, it's more for debugging purposes. It just gets a list of the last connected clients, which synchronize the time with the services. So there are a lot of NTP servers with this function enabled. Open resolvers. Now this is to talk about DNS. How many of you know about the Open Resolver project? Okay, cool. So open resolvers are basically DNS servers which answer to queries outside of their administrative domains. And we have many of them. Do you know maybe how much? Yeah, it's 30 million. And like 28 million for them are exploitable in some way. So if you're running a DNS server, please make sure that it's only answering to queries within your domain. So unless you're like building for OpenDNS or Google, but that's another story. So amplification factor, as you can see, MTP jargon, pretty nice amplification factor. The DNS amplification factor varies. Why is that? Well, because it varies on the query you are using, because DNS has different record types used for different things. So for instance, there is this any query which return all of the record types, which is really bad and should be disabled. Also, people for some reason are hosting huge TXT records. Like I've seen TXT records with like poems and literally works. I don't know what was the use of that, but yeah, we have it. Yeah, this is example querying for NTP server with this command enabled and a small code how to utilize that to your own purposes. SSDP flood. Now, SSDP flood is a relatively new attack vector, although we had this SSDP protocol for some time now. SSDP is one of them plug-and-play protocols, and a lot of like printers, web cameras, routers have this protocol, and it's quite useful. It allows for automatic device discovery, but the problem is when the same device has a public routable IP, then you can make it, then you can use it to make a reflection attack, resulting in this payload. So it's interesting because we had, I think, SSDP since maybe 99, 2000, 2001, but it took like 13, 14 years, I think, until somebody has thought of to exploit it. So if you have a router at home and it supports SSDP, chances are you were taking part unwillingly in a DDoS attack. DNS reflection flood, so basically, same scenario. Attacker commands the compromised machines. The compromised machines, they spoof the intended victim's source IP. They query the open recursive servers, which send the huge UDP payloads to the intended victim. TCP-based attacks. Now, TCP takes care of the state. You have the usual story. You have the three-way handshake. It establishes some kind of a verification. So out-of-state floods, as we told, different flags which don't, and random sequence number, which are not part of an already established connection. Rainbow floods with different flags turned on, which do not make sense, do not go together. TCP anomaly, badly crafted TCP packets, and this is important to know because TCP has this transmission control block, which is a data structure within TCP which holds information about the current connection. So each time a SYN packet comes in, this TCP will hold information about things like source, destination IP, next sequence number, things like that. So being data structure, it's a definitive resource, and you cannot have an unlimited number of them. SYN rainbow floods. So for instance, this is down the rainbow flood with different TCP flags turned on, which are not valid because at the same time you have the SYN and reset flag. So why do you want to speak with me at the same time and terminate the connection at the same time? Application layer attacks. Now, as we told, these are layer 7 attacks, and they can be a variety of things. So what makes for a good layer 7 attack? Well, you have basic HTTP floods when somebody just tries to get a slash, but they're pretty obvious and easy. You got randomized HTTP floods where people will feed different user agent values, and they will probably do some investigation, some web scraping of your site before they launch the attack, and they will pretty much randomize it, so they will be harder to catch. Also, when they do such a thing, they want to bypass the cache, because if you have a, I don't know, let's say a varnish cluster, which is really good at serving static content, you don't want to hit the varnish, you want to hit the backend, you want to hit especially the backend logic of the application, you know, because yeah, you want to hit the databases, you want to call some slow queries, you need to do some serious damage. HTTPS floods are basically the same thing, just yeah, with on TLS. SSL renegotiation attacks. So this is now luckily a thing of the past. It basically when during an SSL handshake, when it's established, the client then requests a protocol renegotiation, which is much more expensive on the server side than on the client side. Usually now renegotiation is disabled pretty much everywhere. Okay, so this is a malicious GET request. Does anybody see why it is malicious? A tip, it's not because the accept language is Chinese. Nope, that, but why? Is the wildcard invalid? Nope, nope, not that. So there are different things. First thing that are interesting is, well, Pragma and cache control headers. So they're like really using legacy cache headers, everything, because they really want hard to bypass cache. But this is not an indication of a malicious request. A true indication of a malicious request is that, yeah, by specification, there needs to be a space between the key value pair. So between the header name and the value. And here on the host header, you don't have a space. It's just everything written together. And the same thing with connection keep alive and cache control. The C is spelled lowercase. So this is indicative of a automatized attack, because the people who make this kind of attacks, they don't make a huge effort to implement all aspects of every RFC there is. So it's just like small things like this that are that giveaway. Detection, how to do proper detection. Well, first you need to know your RFCs, so you need to know what's valid, what's not, what's written, you know, in like a good specification, what's not. Also false positive versus false negative. Now a mitigation, and it's not really an exact science. Sometimes you will over mitigate because some legitimate client was caught in the rule you wrote, or you're under mitigate and something goes under the radar. Another thing to use is anomaly detection, basically delta calculation, when you just profile the client's traffic and over a series of a few weeks. And then with this engine, you decide, you tell it's like over a period of 15 minutes, more than 20% packet per second variation is not accepted. So when these thresholds are reached, you'll get a notification, and then you go and manually check these things out. Of course, you can also use ready appliances, which have their own detection mechanisms in it. So you just plug it in inline, they analyze the traffic, and they just warn you, detect if something might be happening and something is wrong. Graphs are really useful, super useful, because graphs are often a dead giveaway, especially in volumetric attacks, when you just see things like this. I mean, this is obviously not a flash crowd, because yeah, it's just like from 0 to 1. Into the hacks, well, of course you need to do a lot of TCP dumping, a lot of packet analysis, and if you do it a lot, you'll get like 6 cents at pattern detection. You'll recognize certain patterns happening all over. You'll maybe get even to know the traffic of a certain client if you're working a lot on their network. So yeah, sometimes you can caught it even by using your eye. So packet forensics. This is an example of two packets with TCP synth-like enabled, so the start of a handshake, and one of them looks a bit strange. I don't know if you can see it from here. Yeah, I think you can. So, okay, so although, does anybody see maybe what's wrong with any of this? Like one of these two might be a bit suspicious. So it's really strange for SYN packet to carry a payload. Although it's not against RFC, and there is this like thing like called TCP fast open, which is still like experimental, and it's not in use. You know, it's not a direct indication that it's malicious, but yeah, I would definitely watch out for it. Mitigation techniques. So we got here a wide variety of different mitigation techniques. Some of them are so obvious as rate limiting, meaning from a single source IP, I don't want to see more than 100 concurrent connections or more than, I don't know, 10 new connections per second. ACLs help. You always try to block the malicious traffic upstream, always, so it doesn't influence the rest of your infrastructure. So you can use just your edge routers control list, where you can match on specific ranges or on different combination of TCP flags. Black holing is the thing ISPs do. Yeah. Source-based null routing is basically the same thing, just based on the source address. Stateful inspection devices, which are basically the appliances that do stateful inspection and signature matching. SYN cookies. Now, what are SYN cookies? SYN cookies are a method to detect spoofed SYN packets. So how do they work? Well, the cookie value, so when an attacker launches a SYN from, with a spoofed IP, the receiver, it gets that SYN, it drops it, but it calculates also a value, which is made up of source IP port combination, destination IP port, secret seed, and initial sequence number, and then sends it back with SYN ACK. Now, if he gets the final ACK, meaning if it's a valid client, it's able to reconstruct the connection just from that SYN cookie. Header order for layer 7 floods, they're also sometimes a giveaway, because some of these devices, these attacks utilize a specific header order, so you can, I don't know, use things maybe like, I don't know, snort or something just to match the header order. DNS truncated bit, it's a method against protecting from spoofed DNS floods, because by this you indicate that you don't want to talk via UDP. You are only interested to talk via TCP, because DNS primarily works via UDP, but there are some things like zone transfers which require TCP, because you kind of want zone transfers to be reliable. And network ingress filtering, which is, I think, everybody running any network should implement. It's a way of verifying that the originating packets fit to your network. So meaning that you're serving from that network. It's basically a good neighbor policy because you're not benefiting yourself by implementing that, but yeah, it's a good thing and everybody should have it. Also, of course, there are some things like for layer 7 floods, if they're initiated by a botnet, you can send them JavaScript, like redirect cookie or something, because some of them cannot follow it. Well, the mostly new botnets can, but it's worth a try. Different solutions when it comes to mitigation. Of course, you have on-premise devices, you have cloud, and you have hybrid solutions. On-premise is basically you have your own device there, you have your own appliance. Cloud is utilizing different cloud providers. Hybrid is having an on-premise device, which if certain patterns are matched, just activates and you're routed to the cloud. Yeah, often with the cloud, there is different ways to implement it. So you can put your services behind the CDN. So CDN, it's like every host is made like a bastion host. So they utilized Anycast, or they do some DNS magic where your site will always resolve to the like a nearest server, nearest edge server to your original client location. I'm running out of time. I need to speed things up a bit. And cloud DDoS solutions. Well, so as I said, you can put your site behind a CDN, but you can also utilize a GRE tunnel to announce your prefixes over a cloud DDoS solution, where they become effectively your ISP, and all traffic needs to go through them before it reaches your destination. So here I know that there is this term called mitigation center, scrubbing center, DDoS protection center, which is basically data center focused only on scrubbing bad traffic and forwarding the good traffic. They're usually manned by 24/7 SOCs. They sometimes have an SLA, sometimes they don't, meaning that some of them say, okay, we will mitigate this kind of attack in so much and so much time. They leverage Anycast, so not a single scrubbing center sees the full-blown attack, because yeah, as said, distributed attack require a distributed defense, and also gives that the attack traffic is not routed through the whole globe. They have usually terabits of attack capacity. They also feature some kind of threat intelligence, so they might know sometimes that an attack is going to happen before it actually does. They also do zero-day stuff, and yeah, that's it. And woohoo. Okay. So guys, I'm up for any questions now. Thank you for listening. Yep. Oh, yeah, sorry, you have to...
Hi, quick question.
Yeah.
Is there a possibility to create 100% protection from DDoS? I mean, if you have attacker who is create basically the same package with size and query like
Yes.
normal user.
Yes, you can do it. Maybe, it always changes. It always, picks the initial sequence number. It always, has the same signature. You're doing some kind of signature matching, because like some attacks, what they do is like, for instance, SYN floods, they have a payload which is like, it's called padded SYN. So like when you open it, you can see just zeros, or you can see like the F word continuously like going.
Okay, so but that is
But
human interface, not automatically stuff.
No, not automatically, because it's yeah, machine learning isn't so advanced as it's yeah, it's just the state of things. But basically, you need a human every time to make a decision. Otherwise, you could really damage the customer, because you can block legitimate traffic.
Okay, thank you.
Yeah.
Who's next?
Anybody?
How are you?
Good so far.
Have you seen more of these attacks in the last time, especially with blackmailing companies?
Sorry, one more time.
Have you seen more of these attacks in the last time in real field outside?
I'm not actively working in this industry since some time ago, but the truth is, these attacks, yeah, that they're becoming, they're quite common. So it's every time, for instance, especially in, like gambling industries, things like that, it's a totally, legit way of doing business by just knocking your competitor totally off. So yeah, it is pretty much common still. I don't see it going away anytime soon. Okay, thank you. So guys, thanks for listening. If you have any other question, I'll be hovering around here somewhere. Thank you.